Now in this video we're going to look at the Zener diode. So Zener diodes are used to get a reference voltage. So they have rated values. If you look closely at this, you need a loop. It's very, very small writing. But it says 5V6, whichever one of these is the 5.6 volt Zener diode. So a lot of times, since decimal points can't always be seen in small writing, they just use the, in this case, voltage, V for voltage, as a place mark there. So in any case, we need to put current through the Zener diode before it will build up a voltage. As we saw with other diodes, they need a certain voltage before they start conducting. Unlike most diodes, though, like LEDs and rectifier diodes, the Zener diode can conduct well reverse bias. In fact, that's where you get the voltage built up across it. So the cathode, the black band, is actually towards the positive side, where the anode's towards the negative side. Backwards from how you normally see a diode. But in any case, that voltage will build up once current starts flowing through. The exact value will vary a bit depending on the value resistor you use to limit current. And therefore the value of the resistor and the supply voltage may change it a bit. But for the most part, over a wide range of voltages, you should have a fairly accurate voltage at this point. So now that can't power stuff. Remember, the current's going through the resistor there. But you can give other circuitry a signal where it can respond to it. So now to demonstrate this, I got the meter set to measure voltage, and we can go anywhere along the negative supply, anywhere along the positive supply there to get the supply voltage, which is 12 volts right there. But if we come to where this Zener diode and resistor meets, you can see we got 3.3 volts. I'm not making good connections, that's why it's bouncing around. So that's a 3.3 volt Zener diode, which is a value they come in. And this should be a 5.6 volt Zener diode, even though it looks a little bit higher there. And again, that should be a 5.1 volt Zener diode, even though it's a little bit higher. But in any case, we're going to now lower the power supply voltage to 9 volts. So you don't get an exact voltage, but we're within about a tenth of a volt. So I mean, it's close. And the closer it is to 5.1 volt, the more accurate it usually is. So we lowered the supply voltage. You can see it went down a little bit because the current did go down a little bit. Again, the 3.3 volt Zener diodes aren't as accurate, but we got 9 volts at the supply, and we can keep it at ground. That ground goes up to the Zener diode there. Again, 5.6 volts, just a tiny bit lower because a little bit lower current. And we got, it's still showing 5.2 volts right there. Went down a tiny bit, it looks like, but just because there's a tiny bit less current. So we dropped the voltage though down by a fourth. Went from 12 volts to 9 volts. And the voltages are holding, you know, pretty much the same. So, in any case, whenever you're done with the meter, get it, turn it off.